A sailing ship with mass 8.5 times 10 cubed kilograms is initially at rest. A steady wind blows the ship from the west. The ship accelerates a distance of 0.8 kilometers towards the east and achieves a final speed of 8 meters per second. Neglect water resistance. What is the magnitude of the force exerted on the ship by the wind? How long does it take the ship to travel such a distance? So we can use the definition of work and the work energy theorem to solve this. So if you remember, the work done is equal to a force acting over a certain distance, or the product of the force and the displacement, force times displacement. And by the work energy theorem, you get that that is also equal to the change in kinetic energy. And the change in kinetic energy is simply the kinetic energy after minus the kinetic energy before, initial kinetic energy. And they're based on the final and initial velocities of the object. And now we know that the sailing ship is initially at rest, as it states in the problem. So the initial velocity is 0, and this whole side becomes 0. So we can ignore that. So the change in kinetic energy is just simply 1/2 mv squared, where v is the ship's speed, the ship's final speed after accelerating. So all we need to do is plug the numbers in. So 1/2 times its mass of 8.5 times 10 cubed. This is simply 8,500 kilograms times its final velocity of 8 meters per second squared. Now, if you multiply all of this, you should get that it is equal to 272,000 joules, or 2.72 times 10 to the 5th power joules. And that is the ship's kinetic energy after being accelerated by the wind. So now we can use this equation to figure out the magnitude of the force exerted on the ship by the wind. All we need to do is divide the kinetic energy. I'm just going to write it as K, since there really isn't much change. It's just the final kinetic energy, since the object initially has no kinetic energy. Equal to the kinetic energy divided by the displacement. So this is simply equal to the kinetic energy that we just calculated of 272,000 joules divided by the displacement of 0.8 kilometers. Now we first need to convert it into meters before doing anything. So you know that 0.8 kilometers is simply equal to 800 meters, since they're 1,000 meters per kilometer. So you can write this as 8 times 10 squared, but I'm just going to write it as 800. So the average force, or the magnitude of the force, if you calculate that, that should simply be 340 newtons. So that's the first part of the problem done. So I'm going to erase some of this stuff here. Get this up there. So the magnitude of the force exerted on the ship by the wind is equal to 340 newtons. So now we need to figure out how long it takes for the ship to travel the distance of 800 meters. So to do this, we can simply use the kinematic equations. If we look, there's one that says that the displacement is equal to the average of the initial and final velocities divided by 2, just the average of the initial and final velocities times the time interval, or simply just the time. So now we just need to rearrange the solve for time. So if you solve for time, you should get the time is equal to 2 times the displacement divided by the sum of the initial and final velocities. So now all we need to do is simply plug everything in. 2 times the displacement of 800 meters Sorry, that's a really bad equal sign. So 2 times the displacement of 800 meters divided by the initial velocity plus the final velocity. And if you evaluate this, you should get that the time is equal to 200 seconds. So force is equal to 340 newtons, and the time is equal to 200 seconds. And that is how you would solve this problem here.